Welcome to the Explainer. Today we're tackling something huge, a question that's really at the heart of modern technology. How can a machine actually learn to be creative?
Okay, so let's just jump right in with a question that honestly feels like it's straight out of sci-fi. But it's not. It's happening right now. Can a computer have an imagination? I mean, can it really create something totally new all by itself?
And the answer, which is kind of mind-blowing, is yeah, it can. The secret sauce is something called deep generative models. You can think of them as these really clever blueprints that teach a machine how to cook up brand new stuff. Synthetic data that looks so real you can't even tell the difference. So how on earth do they do that?
Well, when it comes to teaching a machine to create, there are basically two big ideas, two different philosophies. You can go the cooperative route, where everyone's working together as a team, or you can go the competitive route, where two different systems are basically at war with each other. So on one path, you've got what are called variational autoencoders. We'll just call them VAEs. This is the cooperative path. It's a team effort, right? It's really stable, pretty reliable, but sometimes the stuff it creates can be a little fuzzy. Then you've got the other path, generative adversarial networks, or GANs. And this is all-out competition. It's a high-stakes game of forger versus investigator, and it can create these unbelievably sharp, realistic images. The catch? It's way, way harder to get right. So let's start with the cooperative approach first, the VAE.
All right, let's dive into VAs, the smart mapper. So imagine this. You want to teach a computer to draw a face. You could just show it a million photos and have it copy them, right? But a VAE does something way smarter. It doesn't just memorize the faces. No, it tries to understand the idea of a face. It learns the rules, the structure, and it creates this perfect, continuous map of every possible face you could imagine. See, a simpler version of this, a standard autoencoder, it's pretty good at copying. It can take an image, shrink it down, and then build it back up. But here's the problem. Its internal map of faces has all these empty spots, these gaps in between, so if you try to pick a point from one of those gaps, you just get nonsense, total garbage. VAEs are the fix. They're designed from the ground up to create a map that is perfectly smooth with zero gaps. And that means you can point to anywhere on that map and get a brand new, totally believable face. So what's the VA's big trick? How does it make this smooth map? Well, it's something called probabilistic encoding. And this is really clever. Instead of telling the VA, this photo of a face belongs at this exact coordinate on your map, you tell it, this photo belongs somewhere in this general area. It gets a center point, that's the mean, and a little blurry zone around it, that's the standard deviation. By making every point a fuzzy region instead of a sharp dot, these regions are forced to overlap. And that overlap is what creates the smooth, continuous space. It's brilliant. It forces the AI to generalize and actually create. And what's so cool about this is that creating something new becomes super easy. Once the map is built, all you have to do is, well, just pick a random spot on it. You grab some coordinates from this latent space, as it's called, you hand them over to the decoder part of the network, and poof! Since the decoder has learned what the entire map means, it just translates those coordinates into a totally new, unique, and believable image. Okay, so that was the cooperative approach. Now, let's switch gears completely. Let's talk about the other philosophy. This one isn't about teamwork and mapping. It's about a high-stakes game of cops and robbers, or forgers and investigators. This is the world of generative adversarial networks, or GANs. And just to be clear, this isn't some small, niche idea. We're talking about a concept that AI pioneer Yann LeCun, a guy who literally won the Turing Award, the Nobel Prize of Computing, called the most interesting idea in the last 10 years in ML. So, what's all the hype about? It all comes down to this adversarial process, this battle, an idea pulled straight out of game theory. All right, so this game has two players. Let's meet player one, the generator. You got to think of this thing as the ultimate art forger, a con artist. Its mission, it takes a bunch of random static, just pure noise, and it tries to spin that into a fake painting, a fraudulent photo, something that looks so real it could hang in a museum. Its only job is to get good enough to fool the expert. And that brings us to player two, the discriminator. This is our Sherlock Holmes, our expert art investigator. Its job is simple, but it's tough. It gets shown a whole stream of images. Some are real from the training data, and some are the forgeries from the generator. And for each one, it has to make one call, and one call only. Real or fake.
And this is where the magic really kicks in. It's a constant arms race. The generator makes a fake, the discriminator looks at it. If the discriminator calls it out, fake, the generator learns why it got caught and goes back to the drawing board to make a better forgery next time. But if the generator manages to fool the discriminator, well, then the discriminator learns from its mistake and gets better at spotting fakes. This back and forth, this minimax game, happens millions of times. And with every round, the forger gets more masterful and the investigator gets more brilliant.
Okay, so we've got these two amazing ideas, the cooperative mapper and the competitive forger. But they're kind of abstract, right? So why should you care? What can this stuff actually do? Well, it turns out these models are the engines powering some of the most jaw-dropping AI applications you've ever seen. This whole competitive game unlocks some absolutely wild abilities. GANs can do something called super resolution, taking a grainy old photo and making it crystal clear. They can do image-to-image translation, like turning a simple line drawing of a building into a photorealistic architectural render. And yeah, this is the big one. They are the magic behind all those text-to-image tools. You just type in some crazy idea like a synthwave cat DJing on Mars, and boom, you get a masterpiece. It's incredible. So let's take a peek under the hood at one of these, a model called Stack GAN. It's really interesting because it doesn't try to create a perfect high-res image all at once. That's too hard. Instead, it works in two stages. In stage one, it's like a painter doing a rough sketch. It just lays down the basic shapes and colors. Then, in stage two, it takes that rough draft, looks back at the text prompt, and starts painting in all the fine details, the textures, the lighting, until you get that final, polished, photorealistic image. But here's the reality check. As amazing as this technology is, it's not perfect, not by a long shot. And the whole reason this field is moving so incredibly fast is because researchers are in a race to fix some pretty major, fundamental problems. And the biggest problem? These models have zero common sense. Absolutely none. They're terrible at counting. You ask for a person with 2 hands, you might get one with 6 fingers on each. They just don't get 3D space, so things can look weirdly flat or have impossible perspectives, and they really struggle with the big picture, the overall structure of things. This is how you end up with those bizarre images, like a giraffe with 2 necks, or a person with legs growing out of their head. It just doesn't understand how the world fits together. But the good news is, these failures are what's driving all the innovation. Every time a GAN messes up, researchers learn something new. And to fix these issues, they've come up with a whole alphabet soup of specialized GANs. You've got your DC GANs for better image quality, your cycle GANs that can translate styles without needing perfectly matched pairs, your info GANs, the list goes on and on. Each one is a targeted attack on one of these core problems. Which brings us to a pretty profound final thought. As these tools get better and better, as they learn to perfectly forge reality, pretty soon the technical challenges won't be the bottleneck anymore. The only thing holding us back will be our own creativity, our own imagination. So the real question becomes, if you can create anything, what will you choose to create? Thanks for joining me on The Explainer.